In this video, we are going to study what we mean by electrophiles and nucleophiles. Now, electrophiles, what you have to remember is these are electron loving species. These are what? These are electron loving chemical species. It means they will be always attracted towards the species which is having electron. Now, electrophiles are of two types. First is positive electrophile, okay, and the examples of positive electrophile, we have H plus, we have Cl plus, chloronium ion, we have bromonium ion, we have iodonium ion, we have nitronium ion. Students, you're going to see these examples in the reaction mechanisms in your higher class. Then we have carbocation also. So these positively charged ions are electrophiles. Now we do have neutral electrophiles. You might be thinking, how come neutral electrophiles are existing? Yes, neutral electrophiles means what? We are having like we have BF3 boron trifluoride, we have aluminium chloride, we also have FeCl3. So what they do is they are in need of electron. We all know that boron trifluoride, aluminium trichloride, FeCl3, they all are the examples of incomplete octet compound, isn't it? So they are also known as Lewis acids. In fact, electrophile is going to attack at the place where more electron density is there. So we can say that the electrophiles during the reaction, where do they attack? Where is their site of attack? Site of attack is going to be where more electron density is there. So does it mean that all the positively charged ions are electrophiles? No. See, we have certain examples of, like we have hydronium ion. Now we all know in hydronium ion, oxygen is stable with the 8 electrons around. Okay. Ammonium also, we know in this all these positive cations, each and every cation is having its 8 electrons in the valence shell. This you will get in the chemical bonding chapter. Okay. So it means all positively charged ions are electrophile? No. Okay. These are the examples of electrophile. So electrophile is done electron loving chemical species. Alright. Now nucleophile, just the opposite of electrophile, you have to remember. Nucleophile are the species which contain excess of electron, okay, and they are nucleus loving chemical species. Okay, normally I recommend the students to remember that nucleophiles are the species which is having electron, okay, which is having electron, and it donates its electron. Now when you remember these two keywords, that it contains electron and it donates electron, definitely it will come in your mind that all the anions, whether all the anions are nucleophile. Yes, all anions are not nucleophile, but yes, certain negative charge ions are acting as nucleophiles. Now which are those certain ions? As you proceed in the organic chemistry in most of the chapters, when you will begin with the reactions, you will come to know, but I'll give you some examples. Okay, negative nucleophile. Nucleophile is containing excess of electron and it will donate those electrons to the species which is in need of electron. So the example of negative nucleophile is hydride. I'm not writing the name, I'm just writing the formula. This is boron hydride ion. Okay, this is aluminium hydride ion. Alright, we have chloride ion. We all know chloride, bromide, iodide ions. Yes, we do have carb anion. Now I hope you can understand carb anion. We know very well what are carb anions. They contain excess of electron, isn't it? I mean, not excess electron, I would say one extra pair is there. So carb anion, okay, in our previous video we have studied this. Carb anion is also acting as negative nucleophile. Okay, now it means, so these are some of the examples. There are many examples, students. I am just giving you the limited examples. This is amino. Okay, then we have cyanide. You just have to look at the negative charge, nitrite. Okay, then we have phenoxide. Okay, we have this carboxylate ion, etc. There are many more examples. So what we can conclude by looking at all these examples, that negatively charged ions, okay, they all are nucleophiles. All right, now I have written here one. It means there is another type of nucleophile also, and it is neutral. The type is neutral nucleophile. Now just imagine, I said that nucleophile is a species which contains electron and it donates electron. Then how come neutral nucleophile can do this? Yes, neutral nucleophile can do it, because if you look at the example, for example, see water molecule. It is a neutral molecule, we all know, okay, but it is having these two lone pair of electrons which can be donated. Similarly, we are having many more examples, but I will write the examples which are very easy for you to understand at this stage. Okay, so ammonia molecule also, students, we know. Now by this time you might be knowing all the functional groups also. So if I write ammonia, I can definitely write RNH2, that is alkylamine, isn't it? Then I can write dialkylamine. Okay, then okay, I'll write here trialkylamine. Still nitrogen contains lone pair of electron. Any other example coming in your mind? There are many examples. So the molecule which contains atom with the lone pair of electron can act as neutral nucleophile. It is neutral, but still it contains lone pair of electrons which can be donated. Now since both negatively charged nucleophile and neutral nucleophile contains at least one unshared pair of electrons, they have strong tendency to donate this pair of electrons to the electron deficient species, and hence, students, nucleophiles are labeled as Lewis bases. So these two terms, what is Lewis base? Lewis base means which is going to donate electron. It is very important for 12th standard reactions. So whenever anybody is asking you what is Lewis base, please remember nucleophile which will donate the electron. And what is Lewis acid? It is electrophile. Okay, it is electrophile which is going to accept the electron. So I hope if you want to look at any of the example, you can pause the video or you can rewind the video and you can note down these examples, as they will be helpful to you enormously in your 12th standard. Thank you, and if you like this video, please click on the icon of like video, and if you think that this video is helpful to you, please subscribe the channel so that I can come up with some more concepts of organic chemistry, physical chemistry, analytical chemistry, etc. Thank you.